Section 2.2, we're going to look at the normal distribution, and a lot of this will be familiar to you from Algebra 2. So, normal distribution, aka normal curve. All right, here's what it looks like. It is symmetric, single-peaked. It makes a bell shape. The mean is the midpoint, so it's basically the same as the median. And then for variability, whatever the standard deviation is, that gives us a measurement of the width of the normal distribution. Okay, these are super important in statistics. There's a lot of things just in life that generally fall into a normal distribution, which makes it really useful for all kinds of research. Okay, so general empirical rule, 68, 95, 99.7. Okay, in a normal distribution, approximately 68% of the values fall within one standard deviation of the mean, 95% are within 2, and then 99.7 are within 3 standard deviations of the mean. Be careful that you do not use this rule on a distribution that is not normal. It does not apply. All right, so something we got to be able to do is use the normal distribution to find area, okay? We are always going to draw the curve and label it. That will help you get full credit on all FRQ questions. Then we're going to perform calculations. Standardize the boundary value means find the z-score. All right, table A, you may have seen that in Algebra 2. It's that big long table that you find the z-scores on the side and the top, and then it has a bunch of probabilities in it. Kind of similar to our table of random digits. It's the way it was done for a really long time, but in 2024 it doesn't really make a whole lot of sense. So we can also use technology with z-scores or without z-scores. So I'm going to show you both. All right, and then step 3, always make sure you answer the question that was asked. Did they ask for a proportion, a percentage, a number? What are they asking for? Make sure you're answering that question. So we'll look at an example. We have some information on the Iowa test of basic skills, and we want to know what proportion have vocab scores that are below the 6th grade level. So the first thing we're going to do is draw the curve. All right, it has a mean of 6.84, and then -1 standard deviation, -2, -3, +1, +2, +3. We're looking at 6th grade, so that would be equal to 6, and we want to know below 6th grade, so that's why we're shading to the left. Okay, now for our calculations. Okay, standardize the boundary again means find the z-score. So what z-score would a vocab score of 6 be? All right, that is going to be equal to 0.54. So you see they drew the same curve, but instead of using 6.84 and then the actual mean and standard deviation, the standardized curve has a mean of 0 and a standard deviation of 1. Okay, and then we could go to our little table, and what is the z-score of negative 0.54 equal? And that would be 0.2946. Okay. Second way we could do it is with technology. All right, standardizing or not standardizing. So steps on your calculator. All right, and I'll actually pull my calculators up and do this one with you. All right, so on a Casio, we got to go to the stat menu. All right, we're looking at distribution, so that's F5. A normal distribution is F1. And we're going to do NCD, that stands for cumulative probability. Okay, and so now we got to enter some values. Lower, we shaded everything to the left. So for the lower boundary, I'm just going to pick a really low number. Okay, so like -1,000. If my numbers were in the thousands, I might do like -10,000 or -100,000. Just something that is really, really low, really, really far left on that curve. Okay, upper boundary was 6. We wanted to know everything that was below 6. That sigma is the symbol for standard deviation, so that was 1.55. And then mu is the mean, so that was 6.84. And we're going to press execute. And that right there is our probability, 0.2939, which is the same as what we got using the table. On the TI, very similar process. DISTR right here in blue, that's the menu we want. So second and distribution. We're going to do number 2, normal CDF. All right, same thing. We're going to enter our bounds. We can leave -1 times e to the 99. That's fine. We can leave that. That's a super low number. Our upper bound is 6. Our mean is 6.84, and our standard deviation is 1.55. and then we hit enter. And there it is, 0.2939. All right, same number that we got. Now, when they talk about using the calculator standardized, okay, so if I go back to my distribution menu, it would be the same thing, but instead of an upper value of 6, I would put an upper value of negative 0.54 because that was the z-score. All right, and then for my mean, I'm going to put 0, and my standard deviation, I'm going to put 1. All right, and I don't know if 0.54 is the right number. I might have been off because it should give us the same answer. But that's another way that you can do that, and we'll talk about why here in a second. All right, when you use your calculator to find areas in a normal distribution, to get credit, you have to show work. And by show work, you have to show what you put in the calculator and you have to label it. All right, so normal CDF, but you can't just write these numbers. You have to say what they are. So my lower limit was negative 1,000. My upper limit was 6. The mean I used was 6.84, and the standard deviation was 1.55. Okay, so you have to write this entire thing, labeling the numbers that you put in the calculator to get full credit. Okay, and then make sure we answer the question that was asked. What proportion? 29.4%, or if you wanted to put 0.294, that would be an acceptable answer as well. But make sure you refer to what that means. That is the percent of 7th graders that fall below the 6th grade level on the test. Okay. We also got to be able to go backwards. All right. So find a value if we're given the area, same steps, draw a normal distribution, perform our calculations, and answer the question that was asked. Okay, so here we have some information about the height of 3-year-old females, and we want to know 75% of 3-year-old girls are taller than what height? Okay, so I draw my curve. The mean is 94.5, standard deviation is 4, so these numbers are going up and then down by 4. I want to know what number here, x, would give me an area to the right of 0.75, because that would mean 75% of the girls are taller than whatever this value of x is. Okay, so one thing is we can standardize, all right, or we can use technology without standardizing. All right, so on your calculator, here's how it works. All right, this time we're going to pick inverse normal. All right, Casio versus TI differences. On the Casio, there's a menu that says tail. Let me actually pull that up for you guys. Okay, so there's an option that says tail. That means like which direction did you shade in the picture. So if I change this tail to right, then my area that I'm going to put would be 0.75 because I want the area to the right to be equal to 0.75. But if I keep this tail as left, then I want the area to be 0.25 because if this is 0.75, then the leftover part is 0.25. Okay. On most TIs, the default is left and you can't change it. It's not even an option there. If you have a newer one or maybe like an 89, I'm not super familiar with those, you might be able to switch back and forth between left and right tail. But for the most part, the default is left tail if you're using a TI. Okay, so we can do inverse norm. All right, area of 0.25 because we're going to assume we're going to the left. Now, this would be standardized. The mean is 0, the standard deviation is 1. That is the standardized mean and standard deviation all the time. And the calculator will give you negative 0.67 as the answer. And then that is the z-score. And we want to know what the height is. So we would put that into our z-score formula and work backwards to solve. And we get 91.82. The other way to do it is still use area of 0.25, but then we can actually put the actual mean of 94.5 and standard deviation of 4, and the calculator will give us the answer of 91.80. Now, you might be thinking, Ms. Beeks, why would I ever do this extra work when I don't have to? And the answer is because sometimes you have to use the standardized curve because the missing piece is not the x, the missing piece is the mean or the standard deviation. So let's look at an example. All right, We have rushing yards for running backs in college football. We know the mean is 790, but they don't tell us the standard deviation. We do know, however, that a running back that had 1,637 rushing yards was the 99th percentile. So what is the standard deviation? Okay, and so I would do my inverse norm, right? And if it's the 99th percentile, then the area would be 0.99, right? However, I can't put a mean and standard deviation in here because I only know one of those pieces of information. So I'm going to leave it standardized, all right, and figure out what that is. And what we get is 2.33. So that means that the z-score that goes with 1,637 rushing yards is 2.33. I can use my z-score formula. I would know that 2.33 is equal to my running back's rushing yards minus the average rushing yards divided by the standard deviation, and then I could solve this for x. And I should get a standard deviation of around 363.52. Okay. So the answer, why would I need to know how to standardize? Like, this is why. All right. If you are given a problem where they give you the mean and the standard deviation, I wouldn't standardize. I would just go ahead and put that mean and standard deviation into my calculator, because why would I do an extra step and give myself a chance to make a mistake? But sometimes the mean or the standard deviation is the missing piece. And in that case, you need to know to use the standardized values of zero, mean of 0, standard deviation of 1, that this is equal to a z-score, and then you can work backwards to find whatever piece is missing. All right, and that's it for 2.2.